Hello there. Now that we have mastered adding matrices and scaling them, let's look at matrix multiplication. In matrix multiplication, things are not as they seem. I can't simply take the corresponding entries and multiply them together. Not only is this wrong, this is very wrong. Turns out things are much more complicated than that. So first, let's look at the dimensions. I'm taking a 2 by 2 and multiplying by a 2 by 2. These are compatible, so the resulting matrix is going to be a 2 by 2. So I'm going to build my shell over to the side here, and put down some lines to denote that it is a 2 by 2. First thing, this top position here is row 1, column 1, and it's built from the first matrix, row 1, and the second matrix, column 1. And I'm going to go across the row and down the column, pairing things up. The 1 gets multiplied by the 2, and then I add 0 times 3. I get 2, and that is this entry up here. The next position. This is row 1, column 2, so I build it from row 1, column 2, and go across the row and down the column, pairing things up. 1 gets multiplied by -2, and then I add the product of 0 and 1. Next position. This is row 2, column 1, and it's built from the first matrix, row 2, and the second matrix, column 1. So now as I go across this row, 3 times 2, and then plus 4 times 3, 6 and 12 is 18. And then the last one. Row 2, column 2 is built from row 2, column 2. And again, you're going across the row, down the column, 3 times -2, plus 4 times 1. -6 and 4 is -2. So, this is our resulting matrix here. Alright, the next one over here, you'll notice that the numbers are actually the same. I just switched the order that they're being multiplied in, and we're going to see what that does to it. So, first thing again, check out the dimensions. They are compatible. Whenever you do these square matrices, 2 by 2 times a 2 by 2 results in a 2 by 2. So let's get this first entry up here, row 1, column 1, across the row, down the column. And as we do that, we see that we get a very different number. We have -4 here, and over here we had 2. I'm just going to fill out the rest of this one. I don't need to showcase all that arithmetic again, but we wind up with this very different looking 2 by 2, simply by changing the order. So this order is important here, and this tells us that the multiplication is not commutative. So the order that you multiply your matrices in is very important. Okay, on to some bigger problems. First, check out the dimensions on this thing. Note, the 5 and the 4 do not match up. These are not compatible. You cannot multiply these matrices together. And just to think a little bit about why that would be, what if I wanted to make row 1, column 1? Well, I would be going across row 1, down column 1, 0 matches with 1, 0 with 2, 2 with 5, 8 with 8, and 4 with, there's nothing for the 4 to go with. That's why it's important that the columns here match up with the rows here. This is just as long as this. And in this case, they're not, so you can't multiply them. But if I switch the order, let's check out the dimensions. Here, they do match up. As I go across the row, 1, 2, 3, down the column, 1, 2, 3, everything will pair. So my resulting matrix will be a 4 by 5, and I'm just going to create the shell for that. And then I'll start putting some lines in to show how big it is. Running a little bit short on space here. Now, normally I would just start with row 1, column 1, go across here, down here, 0, 0, 2, so that up there's going to be a 2. But I also want to show you that you can jump around when you make these if you want to know a particular entry. So what if I want to know this entry over here? What's the position of it? It is row 2, column 4, so it's going to be built from row 2, column 4. And then I'm going to go across there. 2 times 8, plus 3 times 1, plus 4 and 0. So that is 16 plus 3. We're going to have a 19 in there. If I want this one over here, this is a row, oh, I guess I switched them. This is row 4, column 2. So it's going to be 8 times 0, plus 9 times 2, plus 0 times 1 for 18. And we could get the rest of it too. Thanks for watching. Character and Scholarship for Life.